Hi, my name is Botond. I'm a software team lead at ScyllaDB. In the storage team, I lead the repair, compactions, and tools team. I've been working here for 7.5 years, and in that time, I worked on many things, including query optimizations. So in this talk, I want to talk about the future of repair, which is transparent and incremental. I think we can all agree that repair is very important. It is important to have consistent data, but it is even more important to have consistent tombstones in your clusters. And the reason for this is to avoid data resurrections. Data resurrection can happen if you have tombstones that did not make it to every node, and then these tombstones get garbage collected, and there's data which the tombstone should have shuttled, but this data survives on those nodes that the tombstone didn't make it to. So with tombstone GC mode timeout, which is the classic tombstone GC mode, where you have a GC gray second time before a tombstone is garbage collected, you need at least one repair in this period to ensure that you don't have data resurrection, but it's better to do more. With the more recent tombstone GC mode repair, only tombstones that were written before the last repair are eligible for garbage collection. So here it's even more important to repair, because otherwise you will not have tombstone garbage collection. So repair is important, but it's challenging as well. One of the problems with it is that it's slow. It can be slow with large clusters or large data sets, or especially with both. And there's also particular problems like mixed shard clusters. Mixed shard clusters are clusters where not all the nodes have uniform shard count. So some nodes have this shard count and some nodes have a different shard count. And we have tried to eliminate this problem, but it's not fully eliminated. Currently, you also need external tools to schedule repair, either by a node tool, manually, or with some script sending requests to the REST API. Or maybe with cron or some combination of these. Or a more popular choice is to provision Scylla Manager. So the first thing we want to do is make repair incremental. This is something that Cassandra already did. And the idea behind this is simple. Not every repair has to repair all the data. So if you repair your table at least once before, the next repair should only need to repair data that you have written after the last repair. So this way you are repairing only the data that you wrote after the last repair. So the more frequent repairs are, the less work they have to do. And suddenly repairing often is no longer a problem, because each subsequent repair is faster. Another thing we want to do is make repair automatic. It kind of already is if you're using something like Scylla Manager, but we want to move the scheduling into the ScyllaDB core itself. One of the reasons is operational simplicity. No need to provision an external tool anymore. But even more important than that is that external tools can only observe what the database exposes via metrics or via APIs. And even then, they can only observe past and current state of the database, while an internal scheduling can also be made aware of plans that we have in the database. So how we plan to get here? So first off, everything I talked about up until now is tablets only. That means that only tables that use tablets will be only to make use of these features. So to start off, tablet repair is already simpler than vnode repair, because with vnode repair, every peer node in a repair, every shard on these nodes have to participate in the repair. With tablet repair, only a single shard from each of the peer node has to participate. So this is already much simpler, and this alone already solves the problem of mixed shard repair being slow, because now it doesn't matter how many shards each of the nodes have, only one from each node will participate. Another thing we have for tablet repair is that these are executed by the tablet scheduler. So when the user sends a request to repair one or more tablets using this new API, it's not executed immediately. So with vnode's repair, you have the usual repair API. You send a request to it, and then a repair is started immediately. With tablets, instead, when you send the request is saved in the system tablets internal table. And the tablet scheduler will pick up the request from here. So what is this tablet scheduler? So the tablet scheduler's role is to balance tablets across the cluster, to make sure that every node and every shard on these nodes have roughly the same amount of tablets. And we balance this the amount of tablets based on different aspects. Currently disk space, but we also have future plans to use other things like CPU load. So the benefit of using this tablet scheduler to schedule repairs is because it will automatically exclude repairs with ongoing tablet migration. So what this means is that if the tablet scheduler sees that a tablet is in the process of being migrated from one node to the other, it will not start a repair. It will wait until this migration is finished, and then it will start a repair. Another important advantage is that this tablet scheduler has a good overview on the operations that are running on these tablets. So it can make sure that the nodes and shards are loaded uniformly, and not just with regards to repair, but also with migration. So each of these operations has a cost associated with it, and the tablet scheduler makes sure that the overall cost of operations on each node and on each shard is roughly uniform, and we are not creating hotspots. All right, this is all I have. So what all this means to you, the user, is that you will not have to worry about repair anymore. Thank you for listening, and hope you enjoy the rest of the conference.